Hi, my name is Marina Kuzmenko and I am a founder of Petiole. We have created a mobile application, Petiole Pro, for real-time measurements in agriculture. One of our models in Petiole Pro is leaf area meter. However, to understand the overall situation with leaf area measurement tools, I was checking available digital instruments and found ImageJ as one of the alternative tools available for leaf area estimation. I have done a brief research and found that ImageJ is a program for personal computer which is available for Linux, Windows and Mac. It was developed at the University of Wisconsin in the United States of America for processing and analyzing images. Hence, I got this instrument and decided to use it because it's free. But then I stuck. It was not so easy to understand how to measure leaf area with ImageJ without a step-by-step instruction. Hence, I decided to measure leaf area with ImageJ by myself and make this full guide video for other researchers who need to measure leaf area and choose ImageJ for this purpose. For today's experiment, I will have 3 green squares. I intentionally use the shapes of known size to give you the overall understanding of the process of measurement leaf with ImageJ. The length of each side of the square is approximately 2 cm, as you can see by grid paper and thanks to the ruler which we have. Knowing the size of each side, we can suggest and visually see that the area of each square is 4 square centimeters, or not 4. Let's check with ImageJ. To measure leaf area with ImageJ, we need to have a photo of the green squares, or in real life it will be green leaves. First of all, we need to launch an ImageJ application on your computer. Then you need to open this photo in the ImageJ program, so go to File and choose the submenu Open. As you can see now, the photo with green squares is open within the program and we can place this window upon our convenience. Choose the line instrument and make a line on the ruler. This means our line will have a length of 5 cm and we can use distance for setting scale. Go to menu Analyze and choose submenu Set Scale. In the new window, you need to put number 5 next to the field known distance and write centimeters next to the unit of length. Then you need to press OK to apply the changes. After we set the scale for estimation of the leaf area, we can start work with squares. So go to menu Image and choose type 8-bit. This will make your photo black and white. Next step is to go to menu Image, choose submenu Adjust and in available option press Threshold. You can see that the appearance of your squares has changed. For more advanced levels, you can regulate some of the features to change the contour of leaves. However, as of now, we will leave the squares as they are. You can press Apply and then your squares will get black color, but for our experiment, we'll leave them red for visual differentiation. You can leave the squares in red, just closing the window and not pressing Apply. After this step, you need to go to menu Analyze, choose submenu Tools and then go to ROI Manager. The next important thing is to check the 2 options, Show All and Labels. You can see these options in the lower corner of the ROI Manager window. For the next step, you need to choose the Wound Tracing tool from the panel of instruments. Click on the first leaf, press the button Add on the ROI Manager and you can see number 1 on the first square. Do the same with the second and the third square and you will get the numbers respectively. Then press the button Measure in the ROI Manager window and you will get the area of the squares. For our case, we have the first square with 4.2 square centimeters, the second square with 4.91 square centimeters, and finally the third square with 4.12 square centimeters. Also, you can notice the rough sides of each square, and this aspect probably creates some inaccuracy. At the same time, the plant leaves in most cases have different edges, hence it may impact the precision of the measurements as well. Finally, you can export the measurements in a CSV file for further analysis. As you can see, we got more specific and accurate results with ImageJ than estimating leaf area visually. Hence, now I'm curious to compare the results of leaf area measurements by ImageJ and Petiole Pro. This will be a goal for my next experiments and videos. See you, bye!